No problem. All right. Motherboards. So when it comes to our motherboard, right? Um, this is the brain for the computer. This is going to be where everything is being processed. So we put inputs to our computers via our keyboards and mice. We point at the things that we want to, interact with. We type the things that we want to change, and the motherboard is there to take all of the changes that you want to make. A motherboard. I didn't get a, I didn't get a picture of it, but I could pull one up real quick. A motherboard is going to typically look like this, and you got different components that you can either plug into it, those peripherals, or it's just going to live there permanently, such as once you put your memory in here in one of these slots, it'll live there, or your CPU will live there. But this rectangle, this whole thing is a motherboard, and we typically want to put this into our desktop, and then how robust we make this will be the performance that we actually see. So a lot of times when you see when you go to Best Buy or you go to buy your next computer and you see how they're saying, hey, you could get an i3, a i5, a i7, that's telling you what type of processing power that it's able to perform. And so when it comes to that processing power, that computer is going to take everything that you give it as far as a command and break it down to ones and zeros, right? Get that binary instruction. And I'll go back in a little bit on that. But it's going to take every instruction that you give it and try to complete it, right? And it won't move on to the next thing until it completes that particular command. The thing is that it does a ton of commands all at the same time. Well, in human eyes, it kind of looks like the same time, but in a computer world, it's one by one. This is called a task manager, right? So your task manager is running all of these services, all particularly in our eyes at one time. But what it does is that it's running all these things at the same time, and it's constantly going back to these different services, creating completing tasks that each one of these things wants to do, right? So with the computer that I got, I need to be able to run Zoom as well as show you my slides, as well as have a microphone and a camera and talk on the internet and have my antivirus running at the same time down here. Bluetooth is on. I should turn that off. Um, and also that's just what I see is that's important to me. But you also have all of these services too that may be running, may be stopped. But that processing power is going to allow me to do more things at one time. Now, your memory is going to be paired up with that. Your memory is going to allow you to remember to go back to these certain things or to have a lot of applications open up at one time and still have a good um, performance into it. So of course we all seen computers that's been bogged down with performance and it's just kind of lagging along, not really getting there. If we up the SATA, if we up the hard drive space, maybe give it a little bit more space that it needs, right? Or we up the CPU on it to be able to hold more, be able to process a lot quicker and faster, and then give it a lot more memory to remember to go back to all of these services. We'll start to see performances like this: quick, fast, ready to go. That's where going into gaming PCs, it really kind of is remarkable when you think about it. Is that people are able to interact with each other almost in real time, and when you think about all of the components that goes into that, it's happening at split seconds. Split seconds. Where when you mash your A button or controller it's actually putting that input in across the network to someone in California, and they're able to see it almost in real time. So your computer needs to have that type of, when I say robustness, that's what I mean by it's able to take those commands that we're putting in and transfer it into binary information back to someone else's computer to where they could see the results of it. Now, let's go into binary numbers, right? Binary numbers are plain and simple ones and zeros. While we may see the alphabet here, letters, numbers, symbols, the computer doesn't see that. The computer sees one and zero, and one means that it's on, and zero means that it's off. We will get deeper into that in networking. But for right now, just write down binaries, ones and zeros. One is on, zero is off. Whenever it reads, that's the machine language, right? So quote unquote, you could write that down too. That's called machine language, and that's how they talk to each other through ones and zeros. They will then turn that back into something that humans can read and show us the end results of it. All of these things that's happening like that. We already talked about the CPU. Um, but yeah, that's why it's really important when you're going to, look for another computer or you're looking to upgrade your computer, see what you have in place. System information. If you're on a Windows PC, you can go to your system information piece right here and see what you got. Um, I have, what am I looking for? The install memory. Got a lot of memory here. Now, typically, what a normal user will need is probably 8 gigs of memory to be decent, right? To be decent, meaning we're doing regular stuff. We're not doing nothing intensive. What's intensive? Um, Creating a video, being able to download a video in 4K, upload a video in 4K. That's intensive work. Being able to transfer all of that clarity in a video down to ones and zeros, right? Then over to the network and back into a 4K video for YouTube or whatever. So those things are intensive on a computer. But typically, a normal person will probably need 8 gigs of memory. And then when it comes to that iCore, I would say i3, i5. i5 is probably your sweet spot. i7 is a little bit overkill. The reason why I got an i7 is because I needed to do Zoom. And Zoom is such a high resource of type of application that when you really break down that we all have our can y'all hear me? Might need to check your
Yeah,
settings on your computer, Mary.
well, I can.
Okay, appreciate it. Um, the you can get an i3, i5, or i7, so you can see my SATA drive just pop back up, right? Minimize that. Um, oh, I was talking about Zoom. Zoom is such a intensive type of application where we all have our cameras on as well as you can hear me in a real time. I may be a little bit laggy, right? And but that goes with anything. Even if we're talking on a cell phone, I could be in real time a little bit laggy. But Zoom is such is taking my picture and then is taking the picture of my computer and showing you that screen as well as bringing over my voice to go along with it. Those things are all being broke down just in that area. Um, and it takes a lot of resources up to do that. I remember that I didn't have the resources on my computer before, and I would drop the call a lot, or I would have to turn off my computer, my camera, in order to stay connected to the phone call. Because if your network is not really working that well, your video could take up a lot of resources just to kind of bring that feed over. All right.